And what I want to do today, rather than just continue exhaustively showing you all the features of PyGame, I'd like to start making a game so we can just learn some of the features and also learn about the game mechanics just by example. And when you're making a game, well, you need some idea or some inspiration. And so the game that I would like to make this week is inspired by this old 80s video game called Missile Command. And Missile Command is being played here. There's a YouTube video of it. It was available on the Atari 2600, but it was also an arcade game. The arcade game was particularly cool because you controlled this sort of target thing with a trackball, which was, most arcade games had joysticks back then. Trackball was some kind of novelty. So I'd like to recreate not an exact replica of this thing, but some game inspired by this. And the way the game works is there's a missile launcher sort of in the bottom center of the screen. That's supposed to be you. You have a bunch of bases or some kind of city that you're trying to protect. That's these 6 sort of blue things across the sides here. And there's incoming missiles coming. And your job is to launch missiles to intercept those and stop them. So you pick the location you want to launch to, you press a button, and that launches a missile to that location where it will explode. And if one of the incoming missiles happens to be nearby, it'll also take that out with it. Okay? And maybe we'll make something a little bit less frantic and a little bit nicer looking than the Atari 2600 version, which was, a television, a game that you played on your television through some console. Okay. So, like you will do, let's change to our teaching profile. So like you will do, I'd like you to start with one of these. On the course webpage, there's a gameskel.py file, or any of the files that you use for assignment 6. They have the sort of framework for creating one of these 30 frames per second PyGame games. And so start with that. It creates this remember it looks like this. Just creates a blank empty window. Not much you can do with it except quit it. Okay. So that's the plan. First thing you can do, if you like, is change the class name. So instead of my game, let's call it Missile Command. And the only place we use that is down here. Make sure that didn't break anything. Okay. So if we want to make one of these Missile Command games, well, we should think about somehow what the most important thing is that we need from the game, and consider making that first, because we're not just going to make it all at once. And at least the way I see it, somehow the most fundamental thing in the Missile Command game is missiles. So we should start by thinking about how we can implement these missiles, and what missiles do, what kind of things they go through. So what should a missile class do? And sort of the nice thing about games, and video games in particular, is in object-oriented programming, the sort of objects kind of jump out at you. Like missile is sort of a an obvious class that we could have. So let's start by making that. We don't need that. So a class called missile. So first thing we have to do is create a constructor that creates a new missile. And part of that is to give it some arguments that it needs to initialize itself. So, when we create a new missile, what's the main thing that it needs, or the sort of main thing that's determined at the time you create it and that doesn't change? You could say the angle of launch and velocity, but where do those come from? From where? There. So the angle of launch they can be derived from, you can make a vector from the angle and the velocity, but in the game, where does that come from? What determines the angle of launch and the velocity?
User input.
User input. So what does the user do to launch a missile? They click somewhere on the screen, or they move the targeting icon and press the button somewhere on the screen. So really what matters is where that happened, right? The location or the destination of the missile is somehow the important thing. And it's important because it will tell us which direction the missile should be going in, and so on. And it will also tell us when the missile should blow up. Because in this game, the missiles explode once they reach their target. So even if we take that information and we turn it into a vector that tells us the direction of the missile and maybe its velocity, we'll still want to remember where that destination is, because we want to know when it's time for the missile to blow up. Okay? So we'll want a target location. And maybe it's not so critical, because it seems like at least all of the defense missiles, they all start from the same place, that little base in the middle, but we can imagine other variants of the game where they maybe start from different places, like maybe you actually have two bases, one on the left and one on the right, and maybe left and right mouse clicks launch from one or the other. So maybe in addition to a target, we'd also want a source. Okay? So initialize a new missile with source and target. And when someone creates one of these things, the way they're going to create it is by giving a point for the source and a point for the target, and that's just a tuple, a pair of coordinates, an x and a y coordinate. So we save the source, and we save the target. Okay. So that sort of captures the stuff we need to save. And now if we look at the lifetime of a missile, sort of what are the stages of a missile? Initially we launch it, and it travels for a while, and then it explodes. And then maybe it goes away entirely after that. Okay? So there seem to be, a missile can be in different states, right? It can be traveling, or it can be exploding, because exploding isn't just an instantaneous thing. It happens for a few frames. You see these explosions happen. So it can be traveling, it can be exploding, and then maybe it can be just gone or dead. So we may want to save these things. So let's define three numbers that we'll call traveling, exploding, and dead or done. We'll just call those 1, 2, and 3. Okay? And initially, when we create a new missile, we just launched it, so its state should be traveling. It should be traveling off to its destination. Okay. So there's sort of the beginning of a missile. And what kinds of things should a missile be able to do? Well, this missile is part of this game. So it should somehow, as the game progresses, as frames go along, the missile should update itself. So let's say it should have an update method. So update this missile before or after every frame. And it should have a draw method. So it draws itself, and it wants to draw itself on a screen. And this is a PyGame screen, so if you remember from last class, PyGame has this screen class that allows us to, that we can draw things on. Okay. And there's a few other things that we can think of. So there's a source, a target, a state that starts out initially as traveling. There's maybe a speed or velocity. I don't know that's some value we'll have to play with. Let's start with 5. So if we think of it moving 5 pixels during each frame, I think last time we did that, we saw that was sort of a reasonable-ish speed. If not, we can make it faster or slower. So let's leave it at that for a while. Okay. All right, so we can't really do much with this new class yet because it only, it doesn't really do anything yet except create these things. But let's just make sure we didn't break anything. In this case, there's no syntax errors. So in our game, if we want the user to be able to do anything, then we should be able to, the most basic thing we can ask them to do is just to launch a missile. And the way they'll launch a missile is by clicking somewhere. And in PyGame, anything that the user does, whether it's pressing a mouse, or moving the mouse, or clicking the mouse, is handled by creating an event. So what we want to look for are what these mouse events are for PyGame and capture one of those. So let's look that up. PyGame mouse click event. So this is stuff that asks for the state of a mouse. Let's see. PyGame events. Key down, key up, mouse motion, mouse button up. And we probably want mouse button down. So there's a mouse button down event, and that event has a couple of attributes, which is a position and a button. So let's capture that one. That's mouse button down. So that's somebody clicking the mouse button, pushing it down. We will say, so we want to create a new missile. So that would be something like missile. And we want to start it from the bottom of the screen in the middle. So that's self.width divided by 2, self.height. And let's make that let's give that a name. Source. And target, and the target will be equals the event dot position. And just so we can see what's happening, let's print the source and the target. Now, well, we'll try this and then think about what more we need to do. Okay, so here I'm about to click, and indeed this just created a new missile with the source 400, 600. That's right in the middle of this bottom of the screen here, and the target 301, 265. That's where I clicked, and I can do that in a few places. Okay. So, if I'm creating this missile, I should probably save it. I can't just create it and then forget about it. So I should save it. And in a game, it looks like, at least from the video we saw, there can be a lot of missiles at once. Certainly you can launch more than one missile at a time, and actually there's even incoming missiles. So we probably want to keep a list of missiles. So back up in our initialization of our game, we're going to keep a list of missiles. And so it'll start out, that'll just be an empty list. But when we create a new one, we'll add this newly created missile to our list. Okay, that looks like it works. Okay, good. So don't forget to comment our code. User click on screen. Launch a missile. So this will, I mean, if we run it, forgetting about the source and target, we can even print all the missiles. So I click, oops, not missiles, self.missiles. Just make sure we're keeping track of everything we need to keep track of. So there, now there's 2 missiles, now there's 3 missiles, 4 missiles, 5 missiles, 6 missiles. So indeed, we're keeping track of this list of missiles. All right. So right now, missiles don't do anything other than get created. So let's see what other things they might want to do. Well, one of the things I might like to do is draw a missile. or one of the things that I'll need to do is draw a missile. And let's start really simple. And the way we'll draw a missile is just to draw it as a circle. In fact, that's about as good as the Atari game ever got, so it's not too bad. So let's see how we do that in Python, or in PyGame. Okay, so there's pygame.draw.circle. You specify the surface or the screen that you're drawing it on, the color of it, the position of it, and the radius. So let's do that. Pygame.draw circle on the screen. The color was going to be, let's say, red. So red is all red, no green, and no blue. The position and the radius. So the position is just self dot, well, we don't have that yet. So let's say self.position is equal to source. And then it's a radius, and the width we don't use because we don't want that. So I don't know, let's give it a radius of 5, see what that looks like. And we can test that. So we've created this draw function that just draws a little circle at this position of this missile. When should we call it? Well, in our game, when it's time to draw everything, well, we should go through our list of missiles and draw them. Okay? So first we set the background color, and then we say for each missile in self.missiles, m.draw on, and that was self.screen. See how that works. Okay, so right now there's no missiles, nothing is happening. I'll click and launch a missile, and you see it there? So it just appeared right at the bottom here. There's the missile drawn. Right now the missile class doesn't do anything except create itself and draw itself. And indeed, when I created one, so we can do it again just so you can see it. So watch the moment which I click, which is going to be right now, that little missile appears at the bottom of the screen. Okay. What would we like to do next? Well, we'd like these missiles to actually travel, to go somewhere. All right, so let's try that. So in order for missiles to travel, they also then need to update themselves. So when a frame elapses, the missile should move. So we need to figure out how a missile should update itself. And the main thing we want to do is update the missile's position. Okay. All right. So now we have a little bit of math to do. We have this missile. It's at some position, x, y. It has a place that it wants to go, and the place that it wants to go is called target, which is an x and y coordinate. And it's going there at some speed. So the first thing we want to do is figure out, from its current position, which direction should it go to get to that target. Okay? So that means we're going to define a vector. which is we take the target, we take the target, its x-coordinate, and we subtract the position's x-coordinate. And we take the target's y-coordinate, and we subtract the position's y-coordinate. Okay, so we have the target, we have the current position of this thing, and we take the difference between those two. And so what that gives us is a vector that points from the position to the target. Okay? So if we were to add this vector v to our current position, we would land right on the target. Now, we don't want to go directly from our current position to the target. We want to go in the direction of v, but not the full length of v. In fact, what we would like to do is go a length of 5, or whatever the speed is. So we want to do what's called normalizing v. So v captures how we get from where we are to the target, but we want to make that thing shorter or maybe longer. We want to make it so that the length of that vector is 1. So let's see how we can do that. First thing we should do is write a helper function that will tell us the distance between 2 points A and B. So what is the distance between 2 points A and B? How do you compute that? Not a trick question. Anybody know the formula for distance? There's some squares and a square root. Yeah. So the distance between 2 points A and B is well, or actually let's do even better. Forgetting about distance, let's do the length of a vector v. Since we already have the vector v from where we are to where we want to go, all we care about is its length. That's also the distance between the 2 points. So that's easy. That's v at 0 squared. So that's the x value squared plus the y value squared. And we take the square root of that whole thing. Okay. And then we'll say, we take the length of that vector v. And so now we know the length of v, and we would like to shrink it so that its length is 1. Which means we just divide its coordinates by its length. So we say v is equal to v at 0 divided by the length, v at 1 divided by the length. Okay. So write a comment to say what we're doing. We get the vector from position to target. Normalize the vector so its length is 1. Now we multiply by the speed. So v is equal to v at 0 times self.speed get 1 times self.speed. And then finally, we say self.position is equal to self.position at 0 plus v at 0, self.position at 1 plus v at 1. Okay, so we figure out the vector from source, from where we are to the target. We normalize that vector so that its length is 1, and then we multiply it by the speed, so its length is now the speed, which is 5 in this example, and then we add that vector to the current position. So that's just going to move this thing a little bit closer, roughly, well, it won't be 5 pixels because it's kind of variable. A little bit closer to the target. All right, so that's our update function. Probably there's a mistake in there, but we'll find that in a second. And if you look at it back in our game, every time there's a refresh event, 2 things happen. There's an update, which is supposed to update all the game objects, and there's a draw. Well, we're already drawing all our missiles. For our updates, we want to say for m in self.missiles, m.update. So let's see how that goes. Okay, integer expected got float. So here we called PyGame.drawCircle. And it used to work, and now it's complaining that it was expecting an integer, but it got a float. So anybody want to guess what changed now? Why did this used to work before and suddenly it stopped working? No, self.color is still okay. It's self.position. So now we're updating the position of this thing, changing its x and y coordinates. Initially that position came from a mouse click, which definitely landed on 1 pixel, which had an integer x coordinate and an integer y coordinate. But when we start updating it, well, we're adding square roots to it and things, so it's no longer got integer coordinates. So we have to just deal with that, which is the following way. We'll just take our position and we'll round it to the nearest integer coordinates. So we take self.position at 0. Let's call it int position at 1. Let's try now. Oh. So, something's wrong in our calculation. If you saw what just happened there, I clicked and it blew up. So let's see, we'll have to debug and see what's the problem. So we'll do that by saying, let's print self.v. Let's print v. Let's print s. Let's print v again. And see what's happening. That ran off wildly. So we created this thing. We tried to go to, or the vector v was 173 minus 155. Let's think about whether that makes sense. So if I was at the bottom of the screen, at position, it's 200, 600, and I want to go up, then indeed my y-coordinate should be decreasing, so it should be minus 155. And my x-coordinate, whether it increases or it decreases, depends on whether I should go into the left half of the screen or the right half of the screen. So that looks right. But then here we print s, and it's saying that s is 2. So s is supposed to be the length of that vector, and that doesn't look right. Of course. So what's the problem here? Yeah. Yeah, I called the built-in len function in Python, which is giving me the length of the pair, x, there's 2 coordinates, and there's 2 of them, so the length is 2. That was my mistake. The function that I actually wrote was called length, not len. Let's see if that fixes the problem. Whoa, that's weird. Still seems to be some issues, so let's see what's happening there. So that should have stopped when it reached its point, or at least it should have started vibrating back and forth when it reached its destination. Let's try another case. Maybe it will tell us what's wrong. That's not traveling in a straight line, and it didn't go where it was supposed to go. So let's see if we can figure out what's wrong. We get the length, which length is 368. That makes some kind of sense. And the position we normalize and multiply by the speed. So the initial vector v was 4.15 minus 2. Doesn't look quite right. This looks like its length is longer than 5. And so here's where we normalize. Print v. There's the normalized one. That's the distance. Yep. Ah, yes, of course. That there. Yep. So I was subtracting the y coordinate of the target. From that, I was taking off the x coordinate of the position, which of course is not going to give us what we want. So, good. A nice straight line to our destination. And then once we reach the destination, or once we get close to it, well, then the current position is not exactly the destination, so it finds the vector to it, takes a step closer to it, but goes past it, then finds the vector to it, takes a step closer to it, but goes past it in the other direction. So it'll just vibrate there. So we have a working missile launching system now. Just once the missiles get to their locations, they don't explode. Okay. All right. Good. So, so this is the current version of this thing updating. Now, what should happen next? So we've made these missiles that we can launch, and they go to a location, and then they kind of hover back and forth there. Well, that hovering back and forth there is not something we want to happen in the game. So it seems like the natural next thing to do is to have them do what they're supposed to do when they get to their location. So remember, missiles have several states. Up until now, we just assumed that they were traveling, but eventually that they stop traveling and they start exploding. So when we update a missile, there's a few things that can happen. If the state is traveling, then that's what we should do. Okay? And that should be an equality test. If the state is exploding, then we should do something else that we'll have to figure out shortly. And otherwise, the state is dead, then we won't really do anything. There's nothing to do to update a dead missile. Okay, so at some point we have to switch between the traveling state and the exploding state. So when would be a good time to switch between traveling and exploding? So when do you know it's time for the missile to explode? Yeah. So when the missile gets close enough to its destination, it should explode. We can't let it hope for it to get to the exact location because it's taking these steps of length 5. So unless the distance is exactly a multiple of 5 and we don't have any floating point errors along the way, we will never land exactly in the right place. So, so here's a natural place. At this point, we compute the vector v from the current location to the destination. And then we compute the length of v. And well, the length of that vector v, that's actually the distance to the destination. And I would say that if the distance to the destination is less than or equal to the speed, then it's time to explode. Right? If I'm within 5 pixels of where I should be exploding, well, I'm about to move 5 pixels, so I may not get any closer than this ever, so now it's time to explode. Yep?
Is that self-dot state equal to self-dot exploding supposed to be equality or assignment?
This here should be an assignment. I'm changing my state to be exploding. So close enough, it's time to explode. So we can see if that has any effect. We launch a missile. It goes to that spot, and notice how it's not jittering anymore. None of them are. And that's because they've entered the exploding state. And in the exploding state, the update operation doesn't do anything. So nothing happens to them after that. Now, what does the exploding state really look like? So what happens when a missile explodes? Well, it looks different, for one thing. So that means when we draw it, we should maybe draw it differently if it's exploding. So we can start with that. But also, it doesn't explode forever. So at some point, we're going to have to let it go away and get rid of it eventually. So let's try that. So first, the drawing. Your self.state is traveling. Then that's what we do. We just draw it the normal way. Otherwise, if self.state equals self.exploding, then let's just do something a bit simpler and draw it as a big circle. All right, they're even starting to look like explosions now. Okay. Now we want more than that. This exploding state doesn't last forever. It's kind of a transient thing. So at the time you start exploding, maybe you should start a counter or a countdown to say that I'm only going to be there for, I don't know, how long do you think an explosion should last? "20 frames, so about 2/3 of a second. Okay. Okay, so if your state is exploding, then and it's time to update, well, then you count down. And if self.countdown is 0, then you can change your state to dead, meaning kind of out of the game, no longer interesting. So let's try that. So if you're traveling, you draw that way. If you're exploding, you draw with the other way. And after 20 frames of exploding, you will be dead. All right. Good. So a couple of cleanup things then. So we've got this list of missiles, and we update them during every frame by calling their update method, and we draw them during every frame by calling their draw method. Now, so far, we're only been adding missiles to this list. Yep. When the missiles are, once a missile dies, it's no longer needed in the game. And if you're going to play this game for a long time, you don't want to keep this giant list of empty, dead missiles that you'll have to iterate over at each frame. Yep.
If you didn't erase this list of dead missiles, would all that extra, whatever the program's doing, slow it down eventually?
Yep. Yep. I mean, eventually that list of missiles would get longer and longer, so you'd have a list of 10,000 missiles, all of which are dead. But still, every time you update, you iterate over that whole list. And every time you draw, you iterate over that whole list. It doesn't do anything with those elements, but just the cost of looking at them and deciding, oh, they're dead, I don't need to do anything, that adds up. And remember, this is happening 30 times a second, so it will eventually get costly. So, probably the easiest thing is to do something like this, self dot, let's say, clean up dead missiles, and say self.missiles equals m for m in self.missiles if m.state is not equal to m.dead. I think that'll work. So we can create a whole bunch of these things, let them all blow up. We wait for them to die. And now we'll look to see what our list of missiles looks like. There, only one missile in the list the next time. All right. Now we're getting somewhere. Okay. So now we have missiles that will travel. They'll blow up for 2/3 of a second, and then once they're done blowing up, then they go away and they leave the game forever. What else could we have these missiles do to each other, or how do missiles interact in this game? So when a missile blows up, what happens? Yep, it destroys anything that's in its blast radius, say, and that includes other missiles. So we should somehow in our game have this interaction between missiles. Now, where does that interaction happen? Well, we can't put it inside an individual missile because an individual missile only knows about itself. That's something that happens in the game that knows about the whole collection of missiles. So during our update, so we update our missiles, meaning that they travel a little bit, and they sometimes explode or whatever. But at this point, maybe we should look at our missiles and look at the ones that are exploding and see if they cause anything else to blow up. So let's get the list of exploding missiles, and that is if m.state is equal to m.exploding. So for each exploding missile, so it's sitting there at this big red circle. What I want to do now is know if there's any other missiles that are inside that circle. Because if so, then they should blow up. Yep?
Okay,
Yep. So, so I'll go through each really slowly. For each of my exploding missiles, E, I will look at for every other missile. And what should the condition be? Well, it should be something like if the distance from E's position to M's position is smaller than something, or let's put this first. If this missile is not already exploding, and its distance to this exploding missile is too small, and I think the radius we were using was 20, but you probably want to make that a variable at some point, then m dot state is m dot exploding, and m dot count down is 20. And just to avoid some issues, so we update each missile, we clean up the dead missiles, and then check if exploding missiles cause other explosions. Okay. And yeah. So there we get a crash. If m dot state is not equal to m dot exploding and distance, because I didn't define the distance function yet. And for that, we can cheat a little bit. See that? Those are missiles that are blowing each other up. They're not blowing up because they're reaching their destination, but they're running into other exploding missiles. All right. So now we are almost there. We almost have all the things we need to actually start making something we can play. So far I've had the game create missiles that the user launches by clicking the mouse. And these missiles travel and they interact the way you might expect. There's another kind of missiles in the game, which are the missiles that the game launches at the user. So those are not created in response to a user event. They're created in response to just the game deciding to launch a missile. And don't worry that we don't have bases yet or any of those things. We can still get the whole missile mechanics going and then worry about the bases later. So let's think about when should a missile get launched by the game? So a random time interval between 30 and 60 frames per second, or even easier, what if we do something like at every frame we maybe toss a coin and decide whether we launch a missile in that frame or not. But the coin doesn't have to be a fair coin. It doesn't have to come up heads half the time. It can come up heads if we make it come up heads 1 out of 30 times, then that'll be like 1 missile launched per second. And we can see what that looks like. And that's probably a parameter we'll want to tune. So let's say we'll have let's call this a launch probability. And let's make it, maybe they'll launch 1. One per second, and so that means in a particular frame the probability of launching will be 1 out of the number of frames per second. Okay, and then I'll need, if I want to use randomization, I'll import random, and let me remember in the random module Python random float. Maybe it's uniform. Random.random gives you a number, a floating point number in the range 0 to 1. So we'll use that. So when we update our game, so we update the missiles, clean up the dead missiles, we check for explosions, and then maybe launch another missile from the enemy. So if random.random is smaller than the launch probability. So we have this number that's about 1 divided by 33, and we're picking real numbers between 0 and 1. So the probability that we'll get a number smaller than 1 over 33 is actually 1 over 33. And if so, then it's time to launch a new missile. So, enemy missiles come from the top of the screen. So, we're going to create a new one. And so its source is the top of the screen. That means that its y-coordinate is 0. And we might as well make its x-coordinate be random. And anywhere can come from anywhere across the top of the screen. So that'll be the source. And the target we'll make it, it's going to be the bottom of the screen. So that's self.height. And I don't know, for now, until we have bases or things to aim at, we might as well also make it a random spot. Like that. So we create this new missile with that source and that target. Let's see if that works. So we'll wait for it. Here it comes. Missed it. So I would like maybe once a second is a little too high. All right. So we'll have to do some tuning. So let's do a couple of small tuning things now, and maybe we can get to making bases next class. So here's where we launch these new missiles. Maybe the color of those new missiles should be different. So let's say M is this new missile, but let's say M dot color is green. So red, green, blue. Check that. Yeah, okay. And maybe to make our lives a bit easier, we'll say m dot speed. Instead of being 5, we'll reduce it to 3. Or even better, let's make its speed be half of whatever the default speed is. Oops. We append that thing. So we wait for it. Here comes, a pair of green missiles. I would say that the launch rate for those things is still way too fast, at least for the quality of play that I can put out. So I would drop that to maybe something like, at least initially, only once every 3 seconds. Wow, that's terrible. Missed them all. Awful. Here's a... Still doesn't work. Okay. Actually, do you notice that effect there? This emergent thing. If you fire too quickly, nothing works because the first one to blow up kills all of the preceding ones. That's actually a known effect of weapons. It's a problem with making machine guns that fire too quickly, is the bullets run into each other. Okay. I'll get you. There you go. All right, so a couple of things we can add, because I've got them here. I've got a couple of sound files. So sometimes things get more fun just by adding sound. So let's add launch sounds. So when do we launch missiles? Okay. So in our missiles, let's say launch sound is equal to PyGame.mixer. I think the function we want to do is sound. Sound, and the file is in a subdirectory called audio, and it's called launch.wave. We'll make an explode sound. So when you create a new one of these things, we'll play the launch sound. Self launch sound play. And when you explode, which happens here, and we actually see there's a bit of code here where we play an exploding sound, we change the state to exploding, and we set the countdown timer to 20. That actually happens, we copied that code into another place, so it makes more sense then to just define an explode method. That says explode yourself. Because back down here, when we were checking to see which missiles blow up, checking for other explosions, let's just say m.explode. That'll also play the exploding sound. Launch.wave. Okay, we have the sound. Okay, that's good. Did I get the file name wrong? No. Okay. Not sure why that's not working, but I will, I'll sort it out before next class. No, I don't think so. I think this sound thing just takes a wave file. Anyway, I'll get it sorted out and talk about it next class. All right, so that's a good place to stop for today.